Graphing Quadratic Functions, Day 4. In the Big Ideas book, it's section 8.4. How can we describe the graph of f of x is equal to a times the quantity of x minus h squared? So I just want to review the core concept regarding even and odd functions. It states that a function y is equal to f of x is even when f of negative x is equal to f of x. So what that is saying is when you plug in a negative x, so you evaluate negative x for x, your solution is you get your original function. So if you plug in negative x for x and get your original function, we say that the function is even. When a function is odd, if you plug in a negative x for x, so when you evaluate and you plug in negative x and your function, you get a negative function, we say that it is odd. What does that mean? So example number 1 says identify even and odd functions. Determine whether each function is even, odd, or neither. So when we look at example A, if we replace our x with negative x, 2 times negative x is equal to negative 2x, our entire function became negative. So we say this is odd. Example B says g of x is equal to x squared minus 2. So when we evaluate for negative x, we plug negative x into our function. Negative x squared is just x minus 2. So negative x times negative x is x squared minus 2. We are left with our original function. Because our function is the same as our original, when we evaluate it for negative x, we say this is an even function. In example C, if we evaluate h of x for negative x, and we plug negative x in for all of our x's, negative x squared is the same as saying 2x squared minus x minus 2. So you can see that our functions do not match. So when we evaluate that, it does not match our original, and the entire thing did not become negative. So we say this is neither odd or even. Most functions are neither odd or even, they are neither when we evaluate them for negative x. The next core concept that we want to look at says when we have f of x is equal to a times the quantity of x minus h squared. When h is greater than 0, the graph of f of x equals a times the quantity of x minus h squared is a horizontal translation h, units right of the graph. When we have h is less than 0, it is a horizontal translation, the absolute value h, units left of the graph. So what that is saying is if we have a negative h inside our parenthesis, it's going to move our graph right. If we have a positive h inside our parenthesis, it's going to move our graph to the left. The vertex of the graph, f of x is equal to a times x minus h squared, is whatever your h is, comma 0. So when we are talking about what is inside, we always want to think inside is opposite. So it's going to move the opposite direction that you would think. If it's a negative, it's going to move to the right, and if it's a positive, it's going to move to the left. So let's try an example. They said graph g of x is equal to 1/2 times the quantity of x minus 4 squared. We want to compare it to our parent function of x squared. So the red graph to the right is your parent function. The axis of symmetry we can see is x is equal to 0. So it's the dotted line down the center of our parabola, which is x is equal to 0. Our vertex is at the origin, so we have a vertex at 0, 0. There is no stretch or shrink, there is no translation, and there is no reflection because this is our parent function. Now let's take a look at f of x is equal to 1/2 x minus 4 squared. So our axis of symmetry is whatever our h is. So our axis of symmetry is going to be at x is equal to a positive 4. Our vertex is the ordered pair h, comma 0. So inside is opposite, so it's going to be positive 4, comma 0. So we can make a vertex on our coordinate plane at 4, 0. We know our axis of symmetry cuts that in half and is the line x equals 4. If we have a 1/2, so our a is between 0 and 1, we are going to have a vertical shrink of 1/2. Our translation, remember inside is opposite, so a negative h moves our graph to the right 4. And our a is positive, so there is no reflection. So when we graph this, we can find 2 more points. So an easy point to evaluate would be 0. So g of 0 is equal to 1/2 times 0 minus 4 squared. 0 minus 4 is negative 4. Negative 4 squared is 16. Half of 16 is 8. So we have an ordered pair at 0, 8. So we know we have to also have 4 units on the opposite side of our axis of symmetry. Another easy point to plug in would be 2. So g of 2, if we have 1/2 times 2 minus 4 squared, 2 minus 4 is negative 2. Negative 2 squared is 4. Half of 4 is 2. So when x is equal to 2, y is also equal to 2. Again, that has to reflect across your axis of symmetry, and you just graphed this function. The next core concept, you can see that we added a k to the outside. The vertex form, which is f of x is equal to a times the quantity of x minus h squared plus k, tells us that our h moves our graph horizontally and our k moves our graph vertically. So our a reflects our graph. It also goes to show that the vertex of the graph is always at h, comma k. So inside is always opposite, which goes with your h or your x coordinate of your vertex. Outside is always the same, which corresponds to the k or the y coordinate of your vertex. You must memorize that inside is opposite. So if you have a positive h, it moves your graph left. If you have a negative h, it moves your graph right. Outside stays the same. So if you have a positive k, it's going to move your graph up. If you have a negative k, it's going to move your graph down. Let's see what that looks like. So if we use the example -2 times the quantity of x plus 2 squared plus 3, we can use a table of values to plug in or find our information. First, we want to find our vertex, which inside is opposite, so we have -2, +3. We want two values larger than -2, two values smaller than -2. When we plug -1 in, -1 plus 2 is 1. 1 squared is 1. -2 times 1 is -2. Plus 3 gives us a +1. Whatever happens to the right side has to happen to the left. When we evaluate for 0, 0 plus 2 is 0. 2 squared is 4. -2 times 4 is -8. Plus 3 is -5. Whatever happens to the right happens to the left. We can easily then come to our coordinate plane and graph that. -2, 3 is our vertex. Then we have an ordered pair at -1, 1, -3, 1, 0, -5, -4, -5, and you can see that our graph moved up 3, shifted to the left 2, is a vertical shrink, or a vertical stretch of 2, and also reflected over the x-axis. The last one we want to look at is when we have the function g of x is equal to -2 times the quantity of x plus 2 squared plus 3, like we did in example 3. What happens if we move that function +5 units? So you can see that the +5 is inside your parentheses, so it's going to move our graph left. So if we shift our graph, we can just pick some points that are on our parabola, and we want to move all of them 5 units to the left. So you can see our vertex moved 5 units to the left. Both of our points moved 5 units to the left, and we can easily graph our function. So H translates your graph horizontally, K translates your graph vertically. You can now complete the online practice 8.4 or the book pages on page 446.